How did we get to Sesame Street? This will make a lot of sense by the time we get to the end of this talk. But Bert, Ernie, and Elmo are all part of your lives these days. You just don't know it yet. So in the beginning, we had this thing called a hypertextual web search engine. This is back way before probably any of us were even thinking about search engines. And these two guys, Sergey Brin and Lawrence Page, created a paper about how to better index the internet at the time using the link graph. This is trillions of queries a day. Query meaning searches, right? So when you go and you search something, Google's doing trillions of these, a year, and has indexed billions of websites. Today, there are already 3.5 billion searches. And in 1 second, there are almost 85,000 searches that Google has to process and bring back a search result for what you put into the search engine. So this is a massive resource pool for them. Google started, it was found on unstructured data. Remember when you could put a bunch of words on a page and Google's like, hey, you rank for this? That was unstructured data. That's when, and I have extra text on here for you guys so that you can read it later and have it to refer back to. Plus I have links on every page where you can get extra information. Given this is a very heady subject, I want to make sure you have that. So I'm not going to read these to you, I'm just going to summarize. So unstructured data is just information that doesn't really have any organization. It's not predefined. Nobody knows what it means. It's just text in a search that goes back to Google, and Google used things like anchor text and H1s and titles to determine what that page was about. So unstructured data used keywords. So if everyone remembers, you always had, and you still need to do this for other reasons, but it's not because of the reasons you did when Google first started. So titles, if anyone is back in the day, they know title tags were like, they could rank your page, just having a good title tag and a good H1, right? And then also term frequency, inverse document frequency. You still hear people talk about this today, and there are purposes for it, but Google's kind of moved away from this model. So enter machine learning. And there's a whole structural change at Google that went on at the time. If you're someone who loves the history of Google, I suggest looking it up because it's kind of fascinating who were the players for at the time. We don't have time to go into all that today. But so this is where machine learning started. So AI and machine learning often get used as though they're the same term, but they're not really. Machine learning is a segment of AI. And so machine learning allows you to build like a predictive model and to make predictions from things that have not been seen before. It also allows you to add semantics and to add context. So from Google, this is their definition of machine learning. It's a branch of artificial intelligence. And you can see here there's many different kinds of artificial intelligence that they use. And basically, it's a way you solve a problem without codifying. So this means that the way Google organic search was originally done, there were engineers who developed algorithms that they could tweak at certain levels to make it do certain things, and they knew exactly what would happen after. But that's a time-intensive project because they always have to, be coding and testing. So machine learning allows Google to do things where they give it a learning set. The code then determines from the learning set what to do and how to predict what might come next. And they use that in all sorts of different kinds of projects at Google. And this is what it looks like. So when you put in, let's say an image, because they're looking at image search here, and they can identify it through multiple layers of this deep learning network. They can come on the other side and know that that's a cat, a dog, a car, apple, and a flower without anybody inputting that information, without that ever being coded. It learns what that is through the learning set that it was originally given. So Google uses machine learning for a lot of things outside of what's here, but I'm just talking about what we deal with in the search engine. So like image search, it's heavily applied. Maps, Google Ads. The automated Google Ad system is based on machine learning. Snippets are rich snippets, featured snippets. Those are all based on machine learning. Pre-processing for organic algorithms, like I said, Penguin, and they don't use it on Penguin. The Penguin has been rolled up into the core set of algorithms, but it's still its own deal. So that they don't use it as part of Penguin except to pre-process how Penguin's going to work. But things like Panda were. They also say they do not use it in the core organic algorithms, like I said. And why? Because it can get really messy. So when I have an engineer tweak the code to make something rank differently based on, whatever goal we're trying to achieve, then I know exactly what I'm doing. But the problem is when you do machine learning or AI, it does its own thing. The reason machine learning is called they use neural networks is because they're trying to imitate human thought. They don't do that yet, but that's where they're heading. So it can get really messy because, like, if sometimes you say something and then you think it and then you say something else and someone goes, how did you get to there? And you're like, oh, I forgot to tell you the part I thought in my head. Well, machine learning works like that too. You give it input and it can give output, but the people that developed it don't necessarily know why it's doing what it's doing. Does Google use machine learning in organic search? Like, again, I do think they're using it in the core updates, but I do not have any confirmation of that. That's just a personal opinion. But they do use it in language. So this is the primary place where you'll see Google using machine learning. And this is back in 2012, Google rolled out the semantic web, and this is the beginnings of the implementation of machine learning and language, which has developed all the way up till now when we had the BERT rollout last November. And what this is a quest for natural language processing. And you're going to probably hear me say this a couple times, but a lot of people go, oh, Google uses natural language processing. It uses sub-functions of natural language processing in the core of that understanding, but natural language processing would mean if they really could do that, as I talk, you hear me, you automatically know what I'm saying. But this search engine can't do that. It's like an infant. It doesn't really know, right? So noting the knowledge graphs have been around for a very long time. So when you say Google's knowledge graph, it's not the only one, which made academics really, really mad because Google took their term that they used for graph-based knowledge representation and turned it into a buzzword. So just remember, when we talk about knowledge graphs, they've been in existence for way before Google, and Google is not the only one. It's in fact an entire science unto itself. So these are all part of Google's answer engine: knowledge graph, directions and traffic, direct results, featured snippets, rich lists, and discover. And a lot of these are impacted by machine learning. Featured snippets, rich lists, discover, all machine learning. Directions and traffic, also a lot of machine learning. And the knowledge graph is created via machine learning. The holy grail of search is to be able to understand language and text as I speak it or say it instantly. But they're not there yet. But then they added to this knowledge graph relationships and nodes. So now it's not just nouns, but it's also how is it related. So if I say apple pie, it's an apple and it's a pie, but Google knows the relationship between apple and pie is very close, and therefore apple pie is its own entity. So this is when Hummingbird came in and we moved from strings to things. So strings is the bag of words approach where you just type in words. Google doesn't know what they mean, and it's just something they figure out based on indicators to the page, like the links coming in or the title tag. So if a dog is on the page and there's anchor text that says it's a dog and there's a title that says it's a dog, well, then it's a dog, and Google doesn't need to know what that is. But when we moved to Hummingbird, we moved to things, and Google did want at that time to know what the dog is. And then it also wanted to know the relationship between the dog and other entities. So Hummingbird came in 2013, and Google moves from matching keyword terms to trying to process natural language queries using the knowledge graph. So the knowledge graph allowed Google to use machine learning to understand relationships so they could better match user intent and understand what users wanted to come back from the search result. See here, these are all the different parts of NLP, and Google uses some of the blue, all the green in their development of the machine learning process to understand speech better and the relationships between entities so they could bring back better results for you. Page segmentation, where is the information on the page? So Google will still give importance to items above the fold. This isn't just with content, there's other things as well. But above the fold has a Google definition, which I haven't looked up recently, so I'm not going to give it to you, but you can look it up. But this tells Google that this is important, where boilerplate content, like your footer, is not. And then there's entity salience, which just means Google knows something is part of a topic or category without actually having it said. So this page could be about Marvel Comics, but we see Iron Man, science fiction, Pepper Potts, Tony Stark. So this means that these are all related to Marvel Comics. He doesn't even necessarily have to have Marvel Comics on the page for Google to know that at this point. This is kind of what it looks like in mathematics. So the closer something is to the other, the math represents that relationship. But again, Google doesn't process natural language in the true sense, so we have to add an interpreter. And this is actually part of natural language processing theory. So you must have an interpreter when you don't have full NLP. So do you use schema? So I see people on Twitter a lot saying, oh, I added schema and our rankings went up, and therefore schema is part of ranking factors or ranking signals. But it actually isn't. There is a reason that your site did better, but it is not because of ranking signals. So we give our data meaning that Google understands, because Google is not a human, and Google doesn't understand language like you and I do, like you understand as you're listening to me. So that interpreter schema makes a huge difference. Now they think maybe in 5 to 7 years they won't need it anymore, because machine learning will be advanced enough to understand without it. But in the meantime, use schema if you're not using schema, and don't just use Google schema. Google says they will actually use schema from schema.org that they don't list in their developer documents, because the developer documents are for snippet schema. The other thing about schema, it is what they use to identify snippets. You don't have to have it to get a snippet, but you're going to do much better at getting featured snippets, rich snippets, review snippets if you have the schema in the page. RankBrain, I actually discovered RankBrain before RankBrain was known, and had an article sitting at Search Engine Land the day that they announced it, which is kind of funny. And then I had to rewrite the article using the word RankBrain. So RankBrain originally was just for new queries. 15% of all queries Google discovered were new every day, which is crazy to me, because like, how many new ways can you say things? But apparently humans can find a lot of new ways to search for things. So RankBrain at the time was used for unknown queries where entities, meanings, relationships were not clear or unknown. Remember, we're talking about the vector relationship and the mathematical graph, and Google's like, oh, these two things don't seem related to each other. I don't really have an answer for that. And RankBrain just means Google's confused. So Google's like, I don't know. Like, what do you mean by that? So what's the difference between RankBrain and neural matching? RankBrain is about the concepts, and neural matching is just linking words to the concepts. So RankBrain is about the concept suites, and then it brings back a whole search results page, or part of the search results page is affected by RankBrain, but neural matching is the words related to that concept. So now we had this big update back in November 2019 called BERT. BERT and ELMI are Google's algorithms. ERNIE is Baidu's BERT. BERT stands for bidirectional encoder, representations from transformers. Ouch, that's like, what the heck are they talking about? I've given you lots of links here, because we'd have to do a whole hour talk on BERT, and don't have that kind of time. So if you're really confused and like, oh my gosh, because like I said, I could go on for 2 hours about BERT. This is an amazing article written for the layman on understanding how BERT works. It's really good, and I advise anybody who's interested to go read the entire thing about BERT. I'm not going to get into many more details, because you don't really need to know, because it doesn't affect SEO directly. It's easier for Google to answer a question than it is to determine a sentence, the context of a sentence. So when you're optimizing to do better in Google, you want to think not in keywords, but in the intent, the query terms, and the context of those terms to each other within your pages and within your entire site. And then asking and answering questions. Google loves questions, because that's how NLP works on well-formed text, and well-formed text is often a question. So this is the real simple takeaway from everything we just went through. And there we go. That's how I got to Sesame Street, BERT, ERNIE, and Elmo.